Hello and welcome to Graphing Linear Inequalities and Absolute Value Inequalities. Today you're going to need your notes and some graph paper if your notes doesn't have graph in it. If you didn't pick up some graph paper today, go ahead and download some graph paper off my website. If you go into graph paper off to the side, there will be graph paper that you can download, print off, and cut up. Otherwise, do the best you can when graphing them into a regular notebook. All right, and have your calculator handy just in case. So let's review. Graphing a linear inequality. Graphing a linear inequality means you're going to show a region of solutions. So there's going to be shading that's going to be happening. When we graph a linear equation, we only graph the line and the line only. But when we graph a linear inequality, remember inequality means lots and lots and lots of solutions in a shaded region. The line is what's going to divide the solutions from the non-solutions. So you'll have to graph the line to see where the line divides these. Sometimes the line is part of the solution and sometimes it's not. So if it's part of the solution, then it's a solid line. So if it's part of the solution, it's a solid line. Those would be greater than or equal to or less than or equal to inequalities. And then if it's not a part of the solution, then we would have dotted, or another way we could say that is dashed, and those are the less than or greater than signs. Okay, so that's just a quick review. Make sure you write that down. There's a pencil there. All right, we're going to have 3 examples, and you need to write each one of these examples down. So this is graphing a linear inequality. Okay, well, when we graph a line, remember we need the slope and the y-intercept. So if I were to graph this using the slope and the y-intercept, I'd start with the y-intercept of 4, I'd make a point, and then I'd use the slope, which is 2 over 1, up 2 over 1, up 2 over 1. Now this is where in an equation you would just draw a line and arrows on each side. I don't have an equation, I have an inequality. That inequality is a less than sign. That less than sign means we need to have a dotted line. This means the line itself is not included into the solutions. And then I do arrows on both sides, and notice that I divide the whole graph. I don't just do this area right here and make arrows. I do the whole graph so I can see all the solutions from the non-solutions. So then we're going to take a point and test it and see if that is either true or false. Because when we're graphing linear inequalities, we're going to have that shaded region, and we want to make sure that we shade the true region. So the ordered pair I love to try is 0, 0. You could try any point. You could try 5, 4. You just can't try any points that are on the dotted line or the solid line. Okay, so you could even try 7, negative 5 if you wanted to. Any one of those points you can pick up and bring over and plug it in and ask yourself, is it true or false? So if I'm going to use 0, 0, I'm going to plug 0 in for x and 0 in for y. And I'm going to ask myself, is 0 less than 2 times 0 is 0 plus 4 is 4? Is 0 less than 4? This is true. So if this point is true, this point should be true, and this point should be true. And every point over here, no matter if it's in the middle, negatives, in the halves, 3/4, every one of these points would be true. And so I would shade everything in the true region. Notice I didn't shade anything that wasn't true. Okay, so that's how we graph a linear inequality. Let's try it one more time. Now notice this example says y plus 6 is greater than or equal to 0. And notice there's no x. Remember, hoi, vox. Horizontal, 0, y equals. Vertical, undefined, x equals. So if I solve this equation, inequality, excuse me, for y, it would be y is greater than or equal to -6. There's no x here, so this is a horizontal line at -6. So you go to -6, and then you're going to make a horizontal line. But we have to look at this inequality right here. And that inequality says greater than or equal to, so that's a solid line. Okay, and then you want everything greater or equal to -6. So -5 is greater than -6. 0, 0 is greater than -6. This point over here is greater than -6. If you wanted to plug 0, 0 in, just to see that it works, you would plug 0 in for y. You wouldn't plug anything in for x because there isn't an x. And this would say 6 is greater than or equal to 0, and that is true. And so you will shade everything above the line. And the line is part of the solutions, where on the last graph, when it was dotted, it wasn't a part of the solutions. So that's graphing inequalities. Remember shading, testing a point, and shading. So now let's graph an absolute value inequality. So this says y is less than negative absolute value of x plus 2 minus 1. Now we could use a table. Many of you like the table, but we could also use our transformation or our shifting that we learned today in class. So let's talk about all the transformations and all the shifting that's happening. So this says we're going to move left 2. This guy says we're going to move down 1. And this negative says we are going to reflect over the x-axis. So it's going to be upside down. All right, now what's my vertex? My vertex is left 2, which is -2, down 1, which is -1, -2, -1. There's my vertex. And then I didn't have any compression or stretching, so I'll go down 1, right 1, down 1, left 1 on either side until I get my V. Label my vertex, -2, -1. And then I don't need to worry about domain and range at this point. Oh, oops, I need to go back because this graph should be dotted. So say you did this. This happens a lot. And then students write so hard that this is so hard to erase. So what I tell students that if you can't erase, you can say, oh, Mrs. Brendan, I meant for that to be dotted. Otherwise, if you're okay with erasing, you can always plot it again. Oops, -2, -1. Just make sure you do it at the right point. Okay. And then dot your graph. Dot your graph. Okay. So just make sure that you either tell me it's supposed to be dotted or dashed, or make sure that you erase well enough that I can see that it's dotted or dashed. Now, same thing for this graph. I have a shaded region. Notice there's 2 regions. There's one here, and then there's one out here. Okay? And so we have to figure out which region is going to be the true region. So what we do is we plug in any point, okay? And I always like to use 0, 0 just because 0 is so easy to work with. So I'm going to plug 0, 0 back into the original. 0 is less than negative absolute value 0 plus 2 absolute value minus 1. 0 plus 2 is 2. The absolute value of 2 is 2. Times a negative is -2. Subtract 1 is -3. Is 0 less than -3? Now this is 0, 0. I just tried it. No, it's false. That is false. So if that is false, every single point out here is going to be false. So the region that I would want to shade is inside the absolute value V graph. Okay, remember, we're always shading when we're talking about inequalities, and one side will be shaded, the other side won't. So always test a point. Make sure that you worry about dotted versus solid lines or solid V's. Okay? Thank you, and we'll see you tomorrow.